Professor Philippe Gourbesville is the president of International Association for Hydro Environment Engineering and Research, IAHR. While attending the Great Rivers Forum in Wuhan, he shared insights into the future of water engineering and China's contributions to global water management.
Welcome, Professor Gourbesville. You have mentioned that traditional methods are insufficient in the face of increased floods and droughts caused by climate change. So, in your opinion, how is this hydroinformatics, represented by technologies like artificial intelligence and digital twin, bringing about a shift in the governance of global major river basins?
We are facing new challenges in the water sectors. So during centuries, during the recent decades, we have been progressing, developing infrastructures, developing services related to water. We are facing a new situation, which is complexity. We are dealing with an increased complexity in our urban environments, mainly due to the fact that we have bigger cities. So for dealing with this complexity, we need to innovate in our approach, in our concept, just because the concept we were using in the water sectors were used for the past situation. We had, at the end of the 60s, the beginning of the complexity of the situation in the water sectors, competition among users, and at the same time, new technology, what we call at that time new technology, computers, of course, were coming, possibility to simulate and to represent the behavior of the rivers, behavior of the sea, flooding, different processes that we can approach by numerical simulation. That was basically the idea. So we had the concept, but the concepts are not new. We have this idea since decades, but the tools became available with the new technology, and hydroinformatics was formulated with a clear objective to have numerical tools being there to support decision makers for serving the population. So right now, we are achieving, I would say, a second or third circle of development of tools. We are arriving at the fourth generation where we have the capacity to integrate the different dimensions of the water management, not only looking at the river or the small stream or at the ocean, water services in urban, integrating all of those elements to have a global information system regarding water and for a better decision-making process at the scale of the country or even wider.
You have emphasized that technologies should empower people. Now, when applying cutting-edge technologies like digital twin in different cultural contexts, such as Nile and the Yangtze River, how do you make sure that these technological solutions respect and benefit local communities?
We need to tune the things according to the local conditions. The local condition in one catchment, a big river catchment in China, is not something that you will find in a European country, for example, just because the size, the geographical size is different. The level of technology is different. Expectation of the local population is different. Technology is just a tool, so the objective has to be defined locally. So this is how we can be sure that the technology is properly serving the aim and the objective of the local population. And this is something that we see, for example, in China with the Water Commission for the big rivers we have over China. In all of those institutions, we have mechanisms, different type of mechanisms, which are collecting expectation at the local level, could be at the village scale with the farmers, with the different users of the water, to see what they are willing to do with the water and how we can provide the best services, the best infrastructures that are matching their expectation.
China is advancing ambitious projects like the Digital Twin Basin Initiative. So based on IAHR's global perspective, in what areas do you think the global water engineering community can deepen cooperation with China to address common challenges?
Definitely, by definition, the geography of China is extremely diverse. So you have sectors where the water is clearly missing. You have less than 200 millimeters of water per year, and other places you are above several thousands of millimeters of water. So obviously, very diverse conditions. So among the diversity of the catchment in China, you have the possibility to identify the examples that are meaningful and that can support definitely this support. For many countries and for many regions around the world, you can find within the territory of China one place which is almost close to the situation that they are facing. And obviously, it can be a reference that can be used for deploying solution afterwards. So the ambition of China is to have a clear view, a synthetic view regarding the current situation, and to simulate the future. What to do if I create these infrastructures, enlarge this reservoir, reduce this one, allocate more water. You need the tool to have the simulation, which is able to predict what will be the condition in few days, in few months, or even in few years to anticipate what will be the consequences. So by doing that, deploying massive sensors in the natural environment, integrating data, producing information. In some extent, this is a wide experiment which is going on in a huge diversity of catchments. So for the rest of the world, the experience which is now taking place in China is extremely relevant at different levels. Technical approach, how you integrate in the administrative processes, how you organize strategy and decision-making process is something which is very useful. And I'm convinced that a lot of professionals would be extremely interested to exchange with China to see what are the good solutions that could be implemented, how they can be duplicated, or how they can be tuned to fit exactly to the situation that they are facing.
The future of great river civilizations lie in the hands of young people. And as the president of IAHR, what expectations do you have to the future water engineers?
We have different type of profiles. It's a traditional, what you describe as being the traditional equipment, and what was made before, it was mainly electromechanical. So that was the main qualification, because with that you can do wastewater treatment plant, you can do water supply, and we can do all the different type of valve, ship locks that are, for example, used for navigation. So that was the basic background. Civil engineering, hydraulic, hydrology, and electromechanical knowledge. Now, as we are entering the digital age, so it means we need people who can design, operate sensors. So we need people who have advanced knowledge on physics, on electronics, on computer science, those who are interested on AI developments. There are many things where we can play in the water sectors. So very, very diverse profiles that are needed. This is for the technology, but we need also biologists who are able to look at the quality of water, to move forward in the way of analyzing, having better treatment operation, and so on. I would say the list is almost endless, but there are a very large number of professional profiles that could be interested to come in within the water sectors. And this is extremely important, that the water sector is also attracting people who do not have been major or graduated in the water sectors, because they bring diversity, they bring a different view on the things, and this is how innovation in technological field is coming up.
The key to future water management and hydroinformatics lies in data that encapsulates real-world experience. As China pilots new technologies across its vast and diverse river basins, the world can share these lessons and improve water governance together.
Thank you so much, Professor Gourbesville. Hope to see you again in Wuhan.